In this lecture, we will discuss about active filters. We will discuss about first and second order active filters. Filters are circuits that pass only a certain range of signal frequencies and attenuate unwanted frequencies. Filters are classified according to the band of frequencies they pass: low pass, high pass. Passive filters employ only passive components such as resistors, capacitors, and inductors. Active filters use amplifiers together with passive components. Filter type: what type of input, what type of output, and frequency response. We have low pass filter. It allows, this is a low frequency signal, so it allows only the low frequency signal as output. So low frequency signals, this is the gain versus frequency response curve. Low frequency signals are allowed, whereas high frequency signals are attenuated. So this region is called pass band, and this region is called attenuation band. So high pass filter, so this is the high frequency signal. So this high frequency signal is allowed. So frequency response, pass band is at higher frequencies, low frequencies attenuation band. Band pass, it allows only a specific range of frequencies. So this V1 is high frequency signal, Vn is low frequency signal. This is set of frequencies. V2 is the set of frequencies. So this signal comes out. This signal comes out as output. So a particular range of frequency is passed. So this is a pass band. On either side it is attenuation band. And we have notch filter. For a range of low frequency, it will allow. Again, a range of low frequency, it will allow. So this is a low frequency. So it will allow the low frequency signal. It also allows the high frequency signal. So in between, so this signal is stopped. So this is your low frequency pass band, high frequency pass band. In between, this is going to be your stop band. First order active filters, first order low pass filter. A passive Oscillator low pass filter circuit is shown in figure. So R1C1 forms a low pass filter circuit, that is passive filter, that is this I can show like this. So this R1C1 forms the passive low pass filter. This is voltage follower followed by voltage follower made up of operational amplifier. So this forms first order active low pass filter. An op-amp voltage follower connected to its output. The voltage follower functions as a buffer amplifier to isolate the passive filter circuit from the load. Voltage follower eliminates the possibility of load effect on the filter performance. First order high pass filter. The first order active high pass filter circuit is made up of a passive high pass circuit C1 and R1 and a voltage follower, which is a buffer amplifier. The gain versus frequency and the phase versus frequency responses are also shown. So this is the high pass circuit. So here we have a passive filter, high pass filter C1R1 made up of C1R1 followed by this voltage amplifier. So this is the gain versus frequency response. So this is the phase response. So this is the gain versus frequency response. So it's high pass filter, so high frequencies, so higher frequencies are pass band. Second order filters, second order low pass filter. Figure shows a second order low pass filter circuit that has a frequency versus gain response fall off rate of 40 dB per decade above the cutoff frequency. So this is the minus 40 dB per decade low pass filter. So this is its gain versus frequency response. So after cutoff frequency FC, the gain falls at a rate of 40 decibels per decade. This is achieved by using the C1R2 section together with the feedback from the output via capacitor C2 to the junction of R1 and R2. The circuit is known as Sallen-Key filter, also as a voltage controlled voltage source filter, VCVS filter. The cutoff frequency for the second order low pass filter can be shown to be FC equal to 1 divided by 2 pi square root of R1 R2 C1 C2. Next, second order high pass filter. The second order 40 decibels per decade high pass Sallen-Key filter circuit is similar to the low pass filter except that resistor and capacitor positions are interchanged. At high frequencies, XC1 and XC2 are so much smaller than R1 and R2 that they behave like short circuits, passing the input signal unattenuated to the voltage follower. At low frequencies, when the capacitive impedances are much larger than the resistance values, the combined effects of C1R1 and C2R2 produce severe attenuation of the input. So this is the circuit diagram of the high pass filter, and again the gain versus frequency response and the phase versus frequency response is also shown.